Welcome back to CodingCat.dev, where we give you cats the freshest dose of dev snacks. Here is Alex Patterson and Brittany Postma. This episode brought to you by Storyblock. Build anything and publish everywhere. Well, that cut off quick. I don't know what happened there. Welcome, everybody, back to CodingCat.dev podcast. And today on the show, we have Sean Falconer. Hey, Sean, how's it going?
It's going well. How are you?
I'm doing great. Today we're going to talk all about Skyflow and some LLM Privacy Vault, which Skyflow kind of has as part of its offering. Super stoked about that. But before we dive into it, Sean, I need to know a little bit more about you. Can you tell us what's your background? How did you get into this Skyflow thing?
Sure. So I grew up in Canada, but I've been living in the United States now in the San Francisco Bay Area for about 13 years. And my background in training is computer science. So I did 3 degrees in computer science over about a decade. So I have a PhD in computer science from the University of Victoria in Canada. And then I moved to the US to do a postdoc in bioinformatics at Stanford University. So that's kind of like how I ended up here. And then while I was at Stanford, I think probably like a lot of students at Stanford, I ended up starting a company with a couple other students. So I left the world of academics and research and kind of on this path of being a professor to go and do the startup thing full time after we had raised some original like seed money. And then we, so that was around like 2011 or so. And I ran that company for 7 years as the CTO and technical co-founder of the company. And lots of ups and downs. It's all we take an entire podcast to tell that story, but essentially
we've got time. I mean,
yeah. Essentially, after 7 years, I decided we got to the place. The company had some level of success. We were cash flow positive, but we weren't really growing into this monster company that we'd hoped we'd become. And I was kind of ready for something new, so I stepped away from the company, stayed on as a consultant or advisor. And we sold it about a year later. And during that time that I was stepped away, I went and joined Google.
oh, wow.
And I joined Google in developer relations engineering. And I was sort of the founding member of a developer relations. I got to be a startup founder again, but within sort of a massive organization there for a new product area. And by the time I left 4 years later, I was overseeing developer relations and experience for 4 different API products there and had built up a team. And then I left to join Skyflow originally as head of developer relations. And then about a year after joining, I moved and kind of ended up taking over all of marketing at Skyflow.
Oh, that's awesome. That was a fun story too. I have to ask on the Google standpoints to the front, whatever word I'm trying to use here. When you talk about like head of Dev Rel or like a piece of that, Google's often like there's so many products that cross that. What does that look like when you were there? Is it specifically you have these things you're focused on? Like it's not the Angular team, it's not the Firebase team. What was like that core and how did you handle it?
Yeah, so originally when I started at Google, developer relations was its own like org structure.
Oh, okay.
And then about a year or so after I joined, but we would work with sort of the individual product team. So if you were on like Dialogflow or I don't know Firebase or something like that, you were technically part of the DevRel org, but you might go and you spend most of your time or a lot of your time with the product teams and engineering teams of the products that you're working on. But then after a year, they kind of blew up that structure. People got reorged into the individual areas, and this is like a pattern that you see at Google consistently, where they're like, because there's pros and cons of both structures. So you sort of kind of like contracts and expands every half decade or so. So I moved into the comms org at that time, and I was originally focused on a product called RCS Business Messaging or RBM, which was a way to create essentially like chatbots or conversational experiences directly within the native messaging app on an Android device. And then from there, we built out other sort of APIs that address sort of this B2C or like business to consumer conversational experience. And we eventually ended up in cloud, working closely with like, the Google Cloud team across a bunch of different areas. But the main product I was focused on at that time was something called Business Messages, which was a way to bring conversation to Google Search. So you could go and you could do a search for Walmart, say on your phone, And just like you'd have a directions button and a website button, you'd also have a chat button if they were enabled for business messages. And then you could actually have a conversation with either, a bot experience or a live person for customer support or for even shopping and things like that.
I'm sorry, was that Dialogflow that you were part
So
of,
we
or
used a lot of Dialogflow, and I
okay.
did a lot of work with Dialogflow that powered some of these experiences, but the actual front end API for that was something called business messages at that
Ah,
time.
gotcha, okay.
Yeah.
That's super interesting. That's, like, probably pre-AI and everything else that was tied into that too.
Well, at least not the form of AI that we think of
Yeah.
anyway. Yeah.
Yeah, exactly. Not the generative side of it.
Yeah.
I'm super curious on the DevRel standpoint. Like, I've been doing DevRel for like 3 or 4 years now, and I'm curious, what has been the most challenging parts of DevRel for you, and like what has been the best parts of DevRel?
Mhm. So I think the challenging parts depend on the organization that you're at. So when I was at Google, I think the challenge there a lot of times is you spend a lot of time, and this is probably true of anybody that's sort of in a leadership position in a large organization, is you spend a lot of time just on like creating visibility for the work that you're doing and championing it and sort of the politics involved with that. And I think DevRel is in particularly like a difficult situation there where there's less sort of understanding around it. Like if you're in core engineering or you're in a product or something like that, even if you didn't really understand what those people do, there's already just sort of like granted like respect or acknowledgement that they're important strategically
Just
to the
because like they're
organization.
an engineer and they have this thing already?
Yeah, because you're working on core like a core product or something
Gotcha.
like that.
Yep.
So it's they're like, I don't know what this person does, but I know that they build features that like we sell to customers. So,
Sure.
um, and then and then it's the same with product. Product essentially is owning that from a product sense. So you might not understand that, but you know that they have some level of importance. And I think you have to do a little bit more work to kind of earn that within developer relations. It's not just kind of like given to you. So I think I think that was like one of the biggest challenges I had there was just all the work that it took you end up spending a lot of your time just on sort of visibility, championing yourself, getting resourcing, and less time actually doing like real work.
Sure.
Um,
Yeah.
so some of that's like big company stuff that just comes with being part of like 100,000 person organization. And then I think at Skyflow, our big challenge, and this isn't uniquely developer relations, but where I was really focused on initially is we're a new category of product, which I'm sure we'll get into, but we have new category problems. It's like, being part of MongoDB in 2011 or something, where no one knew what a NoSQL document
Right.
store was. Like, why do I care about this thing?
Yeah.
So your first big problem is like, how do I educate the world about what this thing is, why they
Yeah, you
should
have to
care about
sell
it,
the
what problems
idea, right? Like that piece of it.
Exactly. Absolutely. So I spent a lot of time in my first year at Skyflow, just like sort of talking to developer communities, speaking at events, creating content that connected what we were doing at Skyflow to problems that they either cared about or educating on problems that I think that they should care about as, responsible engineers building products that impact customers.
Oh, yeah. That's super interesting. What's your favorite thing? So like I
Oh,
feel like
yeah.
if I like blogs, video, conferences, what's the thing that like drives you as a DevRel?
I think the I think the biggest thing is I like just talking to people about technology
Sure.
and hearing about interesting projects. And I also think it's always very satisfying when something that you did, whether it was an article you wrote or maybe, the work that I did at Google on owning SDKs and technical documentation, that actually helps somebody accomplish something to do their job better, and you
Yeah.
hear that feedback back to you, like that's very, very gratifying to hear. And I've done less of this at Skyflow, but when I was at Google, I really loved doing hands-on events where you could get a bunch of people in a room for 2 or 3
Yeah.
hours and just teach them like try to inspire them to action and
Yeah.
show them what they could do. And we would take people that had like barely heard of what we were doing, and they would be building like a conversational experience in a couple of hours and be completely blown away but what they created. And then the next week we would see them essentially like pitching major banks in like South America on this type of experience. So that was really, really rewarding just to be able to inspire that action and essentially give them the raw materials to make them be successful. And that's also where when I was in sort of the academic world, what really attracted me to the idea of being a professor was I liked working with students. I liked sort of educating and inspiring them to a career or to accomplish something beyond like what they thought that they might have been able to accomplish.
Yeah, absolutely. I've taught too at collegiate level, and it's hugely rewarding, although it can be frustrating too.
Yes,
So it's
I didn't like grading papers, but
exactly. Yeah, we're on the same page.
mm,
Cool. Well, we're going to take a quick break, and then we'll dive into Skyflow. See you in a second.
How in the world could I forget about this?
There's no need to freak out. We have Storyblock.
Robert, you're right.
But we still need a plan.
Okay, how much time do we have left until the launch?
24 hours.
Okay, let's go.
We are ready to publish.
So let's get this baby online.
Thank you so much, Storyblock, for sponsoring us again this year. Really appreciate it. All right, Sean, Skyflow, break it down for me. I'm going to bring up the homepage just so people can like get a look at the logo here. This is kind of the core of it, right? I see a new LLM privacy vault right on the main page, and that's the reason I kind of reached out. I want to know some more about it, but like break down Skyflow for me a little bit.
Yeah. So essentially, our core product and technology is what's known as a data privacy vault. And really, it's based on a pretty simple idea. And it kind of starts with this question of like, why can't we allow a business to use information like our social security number or our home address or potentially health information to support certain workflows or features without essentially that business having to have full access to the plain text data, and then that inevitably ending up on the dark web because of some sort of data breach. And when we think about how we work with passwords, like from an engineering standpoint, we figured out ways of working with passwords where we're not essentially storing plain text passwords. That wasn't always the case. If you look at what we were doing, 20 years ago, and I wouldn't be surprised if we could, poll people that some of this might be the case at certain organizations still, but like passwords used to be stored in plain text in databases. And then we figured out like, oh, we don't actually need to do that, because the only thing that we actually need to do with password, like the workflow that we need to support, is does the entered password match essentially some existing representation of that password? So we can actually do that through salting and hashing and not have to actually incur the like responsibility of securing the raw plain text password. And if you and a lot of this has gotten better over time, where now we don't even store, most people don't even store like the salted hash passwords within their database. They isolate them within essentially dedicated forms of technology, like an identity, cloud-based identity provider like Okta. And we do this kind of the same thing with credit cards, secrets, encryption keys, or in the real world, a good example would be what we typically do with our finances. We put our money in a bank, and then we use a proxy in the form of like a credit card or bank card to access our money. But for some reason, we haven't historically thought about doing this for something like customer data or PII, personally identifiable information. I think that fundamentally leads to all kinds of problems like data replication, sprawl, and simply losing track of the information over time. We make all these copies of the data in the databases, our log files, warehouses, backups, and so forth. And in a world where we have GDPR, the right to be forgotten, that makes actually like complying with those regulations very, very difficult. It basically makes data protection like intractable, because you don't have a way to make sure that only the right people have access to the data or the systems that should have access to the information. It's a little bit like if you took, instead of having like one copy of your passport, you created like 10,000 copies of your passport and then put them all over the place and tried to protect all those locations. That's a much harder problem to solve than having like a single copy of your password. So to solve this problem, taking it back to Skyflow, is we took really a first principles approach to this, and we created what I mentioned was this data privacy vault, which we made available as a service. And essentially the vault isolates, secures, governs access to sensitive customer data or PII while keeping it usable. And the key here is not just about securing it. Like we store the data so that we can actually use it. It's not that useful if we just, lock it up and throw away the key, but we actually want to keep it usable. And we solve this problem essentially by developing something that we call polymorphic data encryption. So this is kind of our secret sauce. And this allows you to not only keep the data encrypted during rest and transit, but actually while doing operations on the data. So being able to run fully encrypted queries against the data that you're storing in the vault. And then we, of course, need to incorporate all kinds of other privacy enhancing technologies, things like tokenization, regular forms of encryption, using other principles from security like zero trust, isolation, and so forth. So the vault itself lives in an isolated environment, running an infrastructure that's separate from your core systems. Just like a bank vault isn't essentially in your home, it's somewhere else, because that would make your home a target. And it also gives you essentially the tools to run compute directly within that isolated environment on the PII that exists outside your systems. And when we think about the types of workflows that we want to support with PII, a lot of times those are assertions, like I want to know whether someone's older than 18 or 21 or something like that. So you don't actually need to expose yourself to the raw data to answer questions like that if you kind of architect these things right. And what the vault gives you is essentially all the tools to do that in a privacy safe way.
When we start to look at, like, when you say isolated environment, are we talking like it can be hosted on AWS and it's up there? You guys are hosting it as a SaaS only product. It's air gapped. How far do we take this?
Yeah, so it is a SaaS offering, and it's not SaaS in the way that might think of like Salesforce being SaaS. And so there's different deployment models. There's a multi-tenant model, single tenant model, and then there's also ways of essentially deploying within your cloud environment via VPC for certain types of companies that have like really stringent security and regulatory requirements.
Yeah, I
Maybe
would
like a
imagine like
bank.
healthcare and financial are like really strict.
Yeah, I mean, it depends. Like we have a lot of healthcare, like health tech companies, like GoodRx, for example, is a customer of
Okay.
ours. Science 37. There's a Nomi Health, and a lot, of course, in the financial world as well. But really, regulations, data security, potential for breaches, these are top of mind for pretty much any organization in the world because we
Yeah.
all are storing customer data that essentially falls under these various regulations at this point.
Yeah, that's super important. It's kind of funny. So I work at Fusion Auth as my day job, and we do all the authentication side of it. But that it feels like this is starting to get into that next layer when you talk about like the actual data that you're storing and the information inside of, I'd say inside, but that you're storing about people in your databases and things like that. I'm kind of curious how granular you can get with securing that data and like what does it mean to actually forget someone like for GDPR? I want you out of my system, right? Like, how does that actually function?
So I think a good way to maybe start by answering that question is to go through like a specific example of how the vault might integrate into a system. So
Sure.
if you think about some kind of like modern architecture, you're going to have maybe you have a front end that goes through an API gateway to a backend system to a database, and then maybe there's some ETL process that ends up putting the data in your analytics store, like a Snowflake or something like that at some point. And traditionally, we would be passing, let's say, someone's phone number through all of those different systems and storing them in the database, storing them in the warehouse, the backups, maybe log files along the way. So that's leads to this data replication problem that I'm talking about. So then if you need to delete it, you need to delete it in 1,500 places. But what happens when you introduce the vault architecture is it essentially becomes your core infrastructure for your PII. So instead of passing that phone number in this example downstream when you're collecting it, you ideally, from a security standpoint, want to de-identify it as early in the life cycle as possible. Just like when you apply encryption, you want to apply it as early as possible. So you would move essentially at collection that data directly into your vault. And the vault is schema based. We can get into some examples of this, but you could make the vault, you can design it in a similar way that you might design a database in terms of having tables and columns and rows and so forth. And so you could have it essentially map to how you might be storing your customer data today in your application database. And so essentially that data is going to go into your vault. That creates a single source of truth that's isolated and protected outside of your environment. And the vault, besides essentially being in charge of security there, is going to give you a reference to the original data, kind of like a pointer in the form of a token, a vault generated token. So we're talking about LLMs a little bit today. So not an LLM token, but like a vault generated token.
Sure.
And essentially the token has no mathematical connection between the original data and the tokenized data. So imagine like Sean Faulkner coming in as a name, and then the vault's going to generate, ABC123 or some representation of it, but there's no way to reverse engineer the token. And if I collect a bunch of tokens, I can't, because there's no connection between them. It's not like I'm leaking any information about the tokenization schema or anything like that. So now it's the token, or this pointer, to use sort of more of a programming term, that gets passed downstream. So I can store that in the database, and I can put, in log files and create 1,500 copies of it. And it doesn't really matter because it's non-sensitive. So even if someone stole my database, I'm not actually compromising anything because it's just this tokenized data. Sure. And actually there was a data breach recently. I don't want to get the bank wrong, but it was with the bank where they had a bunch of,
but okay.
Yeah. They had a bunch of their credit cards stolen from the database, and almost all of them had been tokenized. And they didn't get in trouble for that. The data that they actually got in trouble for was, for some reason, it's probably a legacy system. Some subset of those were actually encrypted, and the encryption keys were also compromised. So they got penalized for the subset of data that was actually encrypted in an encryption key log. But so this is a way to essentially de-scope your existing systems from seeing any of the underlying data, but giving you essentially a reference. And within Skyflow, we've developed, because of like the polymorphic data encryption that I mentioned, we've developed ways of generating tokens that can still facilitate a lot of workflows, like even analytics, to be able to consistently generate them, or they can be format preserving. So if you have systems, downstream systems, that expect a phone number to still look like a phone number, an email to look like an email, you can create tokenized versions that still have that kind of formatting to preserve those downstream systems.
So what does that look like in your database? If I was to go read it, is it just that it's a random, so like, was it 7 digits for a phone number, whatever it might be, or 9, something like that?
So in a phone number example, it would be, instead of, I don't know, a country code 222 333 444, whatever the original number was, and then it's going to be a bunch of random digits essentially.
It adds on to that for the format.
It depends on it depends. You could still have it look exactly like a phone number. So you have like your nine digits or 10 digits, whatever it is. But it's not the original phone number. Okay. But you have to be careful about that. If like, you wouldn't want to use format preserving where the entropy is really small. So like, 4 digits or something like that, because then the search space is essentially smaller too.
That's kind of what I was wondering. Like phone numbers even are, I mean, these days on compute, they're getting kind of small, for like randomization. So that's kind of
So there's like, but you can't really, because of the fact that it's random. Like if you compromise one, it doesn't give you information about the next one. Versus like encryption, you can use a rainbow table attack where once you've compromised one, then you could potentially you can basically break the other ones. So it doesn't have the downside of that, but still, like if basically the search space is small enough, then there is some level of risk there. So you have to, take those types of things into account. It all comes down to, what is it that you need to do with it? Is it really matter that you are preserving the formatting, or can you essentially swap in a UUID and have essentially a better security posture?
Okay, cool. That's really neat. So I spent like a decade in SAP, and I feel like SAP customers have this problem constantly because they're typically like huge amounts of data, or like Snowflake or something like that. When we talk about Skyflow and like trying to get this so far upstream, like typically in that SAP scenario, you have a lot of that data. Does Skyflow, at least with the like LLMs that we're creating now, does Skyflow sit in the middle between like SAP and then like OpenAI? What does that look like?
Yeah, so I think what you're getting at is, if you're like a large organization that's built a lot of this stuff and does have 10,000 copies of this stuff everywhere, like, do you need to re-architect everything? So of course,
in your like MongoDB example, right? Like when you go to more of a flat structure, you're not relational at all. Like you're dumping that same data all over the place, right? Sorry, I interrupted you. Go ahead.
No. So what I described was essentially the ideal scenario, that you're doing this essentially as far left in the data collection process as possible, but it's an API based service that you're plugging in. So you can plug that in essentially anywhere in the stack that makes sense for you. So a lot of times what we see is, larger organizations that are starting to modernize to the cloud, a lot of the first workloads that they're moving to the cloud is like, hey, I want to be able to take advantage of using Snowflake or Databricks, but I'm also a bank, so I don't want every piece of transactional data of my customer information. in Snowflake because there's no reason to it, but I need to give essentially my analytics team enough data so that they can do their job. And there, essentially, you wouldn't be plugging us in at collection in that scenario, but we can help solve that problem to essentially descope your Snowflake or Databricks instance from seeing any of the regulated data by essentially having the vault sit at the head of the ETL pipeline so that you're moving the regulated data in the vault. And then we're giving you essentially tokenized versions of the data that you can still run analytical operations on them. So like if what you need to do is joins and groups and counts and so forth, like it doesn't really matter that my name is in the warehouse versus some representation of my name as long as it's consistently generated. So that's a very common use case that we see. And then over time, you can shift that left as you essentially adopt the vault architecture, but it doesn't have to be essentially a day one re-architecture. Just like companies moving to the cloud, they don't like it took 8 years, I think, for Netflix to move to the cloud. Like they didn't just shut down Netflix and be like, okay, here's the net new project. We're going to go live in 8 years. Like they did it essentially in stages over time. So a lot of places people will start with net new projects as well. So that was, when IBM became a customer originally, it was with essentially their digital health initiative, which is a brand new project. They were dealing with clinical trials data, highly sensitive, highly regulated, need to do machine learning with it, but they wanted to descope their systems from seeing the underlying data, but still be able to run essentially machine learning on it. And that was something that we were able to help them and plug in very naturally there. But to answer your question around LLMs, one of the, I guess, like good things in terms of from an integration standpoint is that LLMs for most companies are all net new projects. So it's like a very natural fit. Like you're building all new, essentially LLM ops, training pipelines or inference and so forth. So these are all new projects for people. So it's easy to kind of plug in Skyflow for helping with that. And I'm sure we'll get into the details of where we can help in terms of LLMs. But
I think it's a perfect segue, honestly. Like I'm really curious from a LM perspective, how you can like use Skyflow to build those responsibly, ethically, like moving forward, because I think we're getting into this like sensitive area where technology is going faster than regulation will ever be able to keep up with. We saw that in social media. I think we're kind of getting into a new age of it. How do you plug that in? Like, what does that pipeline look for you guys? And if you have an example, you want to show off slides, whatever, let's dive into it. I'm really curious.
Yeah, so maybe I'll start with like the problem. So you mentioned some of the problems. So like there's a whole range of problems around essentially responsible AI. So there's like governance, there's ethics, there's bias. I was actually speaking on a panel last night with it was myself, a professor from Berkeley, and essentially a privacy lawyer for a security company, and talking through sort of all these different issues. And I'm not a copyright lawyer, but there's someone there that speaks to that. Copyright's another big challenge with some of this stuff.
I mean that's might be the biggest one. That's why we just had the writer's strike and everything else.
Yeah, absolutely.
I mean, it's huge.
Yeah, I mean there's also like all the coding assistants that are trained on GitHub repositories, and what's it mean from an open source licensing standpoint. And we're really in net new ground in terms of even like I think copyright law or some other type of law has to evolve, because we just don't have essentially the legal tools in place to even deal with this, because it's all so new. If you look at like we're kind of going on a tangent here, but like Google Books from like a decade ago, they originally got in trouble for essentially taking all the books from a library and digitizing them and making them available through search. But then they were able to like comply with the legalities of that, because they're only showing a snippet of it and still they're gating it, and the original author is still getting some financial reward from the purchase of it and so forth. But in the world of LLMs, that's a much harder problem, because the product essentially of digesting all the data isn't essentially it's a derivative version of it. Like it's hard to get an exact quote out of an LLM. You get some like version of it that was inspired by it, but it's not. And it's like, is that copyright or not? Anyway, so in terms of privacy, the big challenge that we have is that LLMs and AI models in general, they're like designed to learn. They're not designed to unlearn. So this means that if we use essentially customer data or employee data or core intellectual property for a company to train a model, you can't really take it back, at least, not in a reasonable or cost-effective manner. And there's some new research in this area in terms of like trying to delete models and information from models and stuff like that. But it's super early, and we're happy to discuss it if you want. But there's and essentially there's existing tools that will help a customer decide what they want to share with a model, but you as a business still can't comply with a deletion request if it comes in,
Yeah.
because there's no row. It's not like a database. There's no row to go delete
Right.
this thing. It's completely new. So I think the big question this raises is that how can you train an LLM on proprietary or customer data, but still make sure that only the right people have access to it, and you can delete it if you need to. So that's the like central challenge that companies are trying to solve right now.
Yeah, I think the interesting part, I heard this the other day, and it was I'm totally gonna ruin what it was, but they basically took like 100 people and took all of their like health data, shoved it into a system, and one of them said, "I don't want my information used," and it threw off the entire model. Like it skewed it so badly because it didn't. They couldn't figure out how to get that back out, right? That single individual, and it kept coming up with like results of a person that is, my middle aged and this weight and this height is X. And they're like, we pulled that out. It still knows it. It's too difficult. So I'm kind of curious, when you start again shifting that further left, let's say if it's actually, it wouldn't be shifting left. If it's already in, can Skyflow help with that? Or Skyflow like has to kind of sit on the left side before it gets in there?
Yeah. So
to
if you've already trained a model with, I don't know, your customer social security numbers, then you're like, there's not a lot of options.
You might want to delete that model.
Yeah, you might as well delete it and start again. And like
Okay.
that,
What's
if
what's an example? Have you guys run into that where someone came to you and you're like, you need to start over? Is that something you've dealt with?
no, I haven't seen that. I do think that we're certainly in a little bit of the wild west of
Yeah.
AI right now, where I'm sure some of that is happening, where people aren't thinking about this. But we have seen, we have a customer, for example, that is in the health tech space using doctors' notes as their training data. So then we essentially help them anonymize the doctor's notes as part of that AI training pipeline. So, but they knew ahead of time that like we have doctor's notes. It's highly regulated. Would be a bad idea to train the LLM on the raw materials.
Sure.
So they recognize that problem up front. And I think a lot of people in the sort of highly regulated industries understand that, but it's easy to not be thinking about that, because you're thinking more about like go to market and speed and like I'm solving a problem and why wouldn't people want this? And that's kind of where we got into trouble, I think, even in over 10 years ago well, 20 years ago in like the early web, and then like with early social as well.
Yeah.
We created essentially business models that were incentivized to hose up as much data as possible because they're using the data as a monetization means. And I think we have a similar challenge in the world of LLMs, because essentially data is the love language of AI. We don't have these amazing tools if we don't have the data to essentially train them on it. So there's an incentive to suck up as much data as possible, but that also creates all kinds of data nightmare challenges to solve, both from privacy and some of these other things that we've been talking about. But here I can show a little bit, maybe we can jump to a slide and I can show a demo here too, if I can share my screen.
Yeah, go for it. And I'll tell a story while you're doing that. I think it's really interesting that we're getting into this scenario again, that tech companies are willing to do the wrong things to get ahead, and then they'll take the penalties later. And it worries me a little bit. I think Google has done a great job. I've seen them like really come out. We need to attack this with all the privacy and like concern and everything else. I haven't seen that, and I'll just say some of the other AI and LLMs that are being built. So I really love this discussion around that, and I hope that people are thinking about this before just like jumping into action and doing it.
Yeah, I do think that we're in a better place than we were, a decade ago. I think the world, like even like consumers, are a lot more aware of their own rights when it comes to data and their digital
Yep.
footprint today. And I think businesses are more aware of this, and we're seeing a lot more momentum, I think, around people like really wanting to solve, even outside of the world of LLMs, like truly solve these problems, which is you know, great for in terms of for Skyflow. But the the um, so they're not just trying to essentially do a bunch of checkboxes on some sort of compliance checklist, but really fundamentally solve these problems so that they are able to use trust and privacy not only as to satisfy some regulation, but also use it as a way to differentiate themselves. Like I think Apple is a great example of a company that has really championed privacy as part of their go-to-market and part of their differentiating factor.
Yeah, I see a lot of marketing even coming back against Google. How what is it? It's essentially a tracking device or whatever they want to call it. So it's a big change. I like it. Do you?
Yeah.
Just one last question before you jump to slides. Do you feel like the U.S. is behind in a lot of these things? Like the European Union, the EU, like keeps setting precedents on all of this stuff and forcing change. Do you feel like the U.S. should be a leader in that, and we're just not?
So I think so. To answer your first question, the EU 100% is ahead of the US when it comes to regulating this kind of stuff. Like there's the EU AI act that is in the works right now and in development. And you can read about it. There's like 4 different tiers of kind of how they're thinking about the severe, like how severe or like the classification essentially of whatever the AI system does, and that depends on like what how strict the regulation is. So, for example, anything around biometrics in the public that does some sort of automatic classification is like a complete no-no. And they were ahead, of course, with even regular regulations. GDPR came in 2018. And I think the good thing about the EU leading the way in a lot of, when it comes to regulations is that it's kind of forcing the rest of the world, and in particular the United States, to have these conversations. Because you're right, like historically, the US has been more like, let's like do something, and then when something bad happens, we will make an adjustment.
Right. And it's so painful to do it that way, and it causes pain is one thing, but like when you start affecting people's lives with it, like now we're in a whole different scenario. It's not good.
Yeah, and I think the pushback against some of the stuff in the EU is, is it too strict, and does that become like a barrier to innovation? And I think that it's possible that it could limit some form of innovation, but I don't think it needs to. Like having trust and security and as core tenets of something doesn't necessarily mean that it has to impact innovation. And I actually think that it can even inspire innovation. So like, I think it's hard to argue that, if you look at building a car, like I can't just go design and manufacture my own car and start selling it. Like there's a bunch of things that I have to go through that are regulated in terms of, like I have to have seat belts. I have to have other, security. Like it's hard to argue that those are necessarily bad ideas. And they've actually inspired, innovation. Or take another example of like, driving while holding a cell phone and talking on the phone. That's a bad idea. But we've created technology that allow us to essentially accomplish that task, but in a much safer way.
Sure.
Or, or you could think about in the medical world, like it takes a long time for a drug to come to market. And there's, certain inefficiencies that might exist there, but like we could go to market much faster if we skip all those things, but we might also kill people. So like, there's a checks and balances that we have to have in place to make sure that people are safe.
Yeah, 100% agree. And one place that I can think of that the US actually did a really good job with that is like the FAA, and having that regulated to like creating the black box was a technology leap forward that was really impressive, but they made them share that with all of the other manufacturers that were in that space, like Boeing and Airbus and stuff like that. So that way, like everyone's on the same page. This is out in the open. You can't just have one secret of why this plane crashed. I think that's hugely important when we get into this AI world of like, here's how this recipe works to a certain degree. Like you can still like make the technology, but when it starts to affect things, I think we need to bubble that to the top and say, you can't do this anymore, right? Like it needs to be shared across everything. So
yeah.
Anyways, all right, shifting gears. Yeah, let's check out these slides. And,
so let's jump into this and then I'll get into some demos. But so when we talk about essentially potentially sensitive data enter the model, there's a couple of different places where that can happen. And the first is around model training. And it doesn't matter whether you're building like a foundation model, you're fine tuning, or maybe using like creating a RAG model or something. You're going to start out with some form of your like sensitive and non-sensitive data sitting somewhere. So these are just examples of like Databricks, Snowflake, and so forth. And we're going to push data downstream to essentially this model training environment. And where Skyflow fits into this world is essentially the vault acts like essentially like a privacy firewall, where it's going, your sensitive and non-sensitive data is going to be fed into the vault, and the vault can detect sensitive data, so like PII, as well as you can configure it to even detect like terms that are particularly sensitive for your business. And the vault is going to store those within the isolated environment, swap them in essentially for an anonymized versions of that data, and create this de-identified data set.
I
Go ahead.
apologize. So is that looking at, are there some out of the box things that you already know, like if you want to protect us from? So it knows a social security number, it knows a phone number, like things like that are built in, but then you're adding on top of it, like for your specific business case, there might be X fields that you're going to look at and you have to kind of train that, or what does that look like?
So yeah, so there's out of the box, we'll do detection for pretty much for basically any sort of form, common form of PII. And then on top of that, you can essentially create sort of your own dictionary of protected words. So a good example would be last year, or maybe it was this year, Apple released like a yellow iPhone. So within the world of Apple, probably in the last like couple of years while they were developing that, the word yellow was probably like something that they wouldn't want Samsung finding out about. It was like a protected, sensitive word within the world of Apple. So they were essentially creating an internal LLM chatbot for their employees. Then they would want to make sure that the term yellow was a protected term and didn't end up in the model, so that it doesn't get leaked to, even people within the organization that don't have knowledge of that project.
And then later on, let's say yellow becomes a thing they want added. Is that just a switch you can flip and take back out and say, go ahead and let yellow in? Or, you know what I mean? Or do they know how to like address the tokenized version of that?
Yeah, so they know how to address the token. So when we're generating the de-identified data, we also have essentially contextual information associated with that. So if it's a name, we can have essentially name with essentially the tokenized version of it, or address with the, so that way the model understands the context of what the tokenized version is.
Awesome. Love it.
Yeah, so then we have this clean data, and essentially we're just going to pass that clean data into the model training environment. So everything works exactly the same. All you're essentially doing is putting this firewall, this privacy firewall, at the head of this training pipeline. And then on the other area where essentially sensitive data can potentially enter the models through inference. So I'm sending in a prompt to my LLM to create some sort of response. So in this example, I'm asking it to summarize a will, highlighting the assets. So here I'm pasting in the document of a will. So clearly there's going to be sensitive data in here. So what we would do is, again, the Skyflow vault would sit at the head of this. So immediately from the UI, the data would go into the vault. The vault would identify the sensitive pieces of information, de-identify them, and essentially create this clean version of the prompt. And since the model was already trained on clean data, then essentially the context as well as the tokenized forms are going to match up. And then when response gets generated from the LLM, the response potentially has de-identified forms of data in it, but we can pass that back through essentially the vault to re-identify those forms of data. So we can generate these tokens in a way that have referential integrity and are also connected essentially to the identity of the user, so that we control whether they have access to this information or not. So if you imagine a scenario where we train an LLM on our company data, then I want to make sure that, the CEO of the company has a different level of access to the responses from the LLM than, Susie in accounting or Joe in customer support.
Sure. Wow. Yeah, I wouldn't have thought about it that way, but that's really cool. And that's that granular piece you can kind of get into.
Yeah, so that's really the core of, I think, privacy. So when we look at some of the things that people are doing to try to address some of the privacy challenges, and a lot of the big cloud companies are sort of promoting this idea of like, hey, don't trust, the open source models, or don't trust the big providers. Come run essentially your private version of your LLM within an isolated environment. But that gives you model isolation. It doesn't actually solve, I think, the core problem, which is, how do I control who sees what, when, where, and for how long? And that's really what privacy is about, is both transparency and allowing essentially the person to only have access to the information that they should have access to based on who they are.
That's cool. Yeah, that totally makes sense. And I think that's like the two layers to it. That's awesome.
Mm-hmm. Yeah, so we can show. So I'll jump into an LLM demo here, but before we go there, just to touch a little bit deeper on sort of how the like governance engine works. So this isn't about LLMs, but this shows sort of how like we think about fine grained access control. So the way access to the vault works is the zero trust model. So essentially no one or no thing has access until you explicitly give it access. And you build up access through creating these policy rules. So you can see some examples here on the left here. And you're essentially explicitly giving access to particular like columns, tables, columns, rows, and how that information is visible. So here, like this marketing person, this marketing role has these policies assigned to it. And essentially they're saying like they can see the name, they can see email, they can't see social security number because they don't need to know that. And they can see basically the birthday because maybe they need to send like a birthday announcement to the person, but they don't need to know how old they are. So that part is essentially redacted. And
That's
because
great.
of polymorphic encryption, this date of birth, this masked information or any masked information, this is never decrypted. So the only thing that's ever essentially in plain text is 0603 in this scenario. So it's different than, essentially dynamic masking and traditional encryption where you need to decrypt the data and then apply the mask. Here, the data is actually coming back essentially in this format. And then if we look at customer support, here you'll see they have even less information like that, the name, last four social for validation, and the state, but they also have a row level restriction where they can actually only see customers in the state of Arizona.
Wow.
And this, solves, I think, a fundamental problem around access control where generally like people just have too much access to stuff. Like if you look at like the Robinhood data breach from a couple of years ago, the customer support person got socially engineered to giving up their credentials. It happens, but that gave that attacker access to 6 million customer records. And there's no reason why a customer support person needs access to 6 million records.
Right.
They probably only need access to the 6 people that are in their queue at any given time. So you can essentially use this policy and you can assign TTLs. You can make this dynamic where you could make it so that the customer support person only has access to the people who are like in their queue at any given time and has limited visibility into the information that they need visibility into in order to do their job.
That's great. I feel like this tells me more and more I don't want to be a CEO because if I have access to stuff and I get socially engineered, yikes! Like take away my access. I don't want.
Yeah, well, you shouldn't have access to probably everyone's social security number and credit card information, or you're in violation of something.
Nice.
Yeah,
well,
so,
I love it, Sean. What other things am I missing about Skyflow? Like high level, can you hit me with anything?
So that's it. I mean, the whole idea is, I think the key idea is that we think about PII data as something special, and similar to how we've learned that like encryption keys are something special. So we, put those in a KMS or, secrets like API keys and stuff like that. Those are special. So we put them in a secrets manager or identity. We use an identity provider. We're extending this same idea of essentially categorizing data into different buckets and based around what kind of data that is. And then developing technology that allows you to do the workflows based on essentially the rules of engagement. So it's similar to like I think a good analogy is if you think of like your home and let's say you had cheese and you have diamonds, you wouldn't put your cheese and your diamonds in the same location because the rules of engagement for your diamonds is different than the rules of engagement for your cheese. And the things that you want to support for access to your diamonds is different. So you put those, you're going to probably put your diamonds in like a safe in your home or something like that, rather than in your refrigerator with your cheese. Because if you put it in the refrigerator, it's very hard to make sure that only the right people have access to it. Yeah. But historically, that's what we've done with data, with customer data. We put it in the same place as all other data. And that makes it really hard to essentially control access because the rules of engagement are different. And even how often you're going to access it is different. Just like cold storage versus hot storage or something. Like, it might be okay that my cold storage is not able to respond to a read operation in under a millisecond, but that's completely unreasonable for my caching system. And we have to be thinking about PII in the same terms of like, it doesn't belong essentially within these existing technologies and storage mechanisms. We need to essentially put it in a special location with technology that allows us to do all the things that we need to do with it, but in a privacy safe way.
That's really cool. Great overview. I like the cheese diamonds. I think that'll have a hot take for people? That's really
Yeah,
good.
I wrote an article for AWS about that. So if you search cheese and diamonds, you might find it. Um,
I'll have to
right.
put it in our show notes. That's awesome.
Yeah, so this is just a simple example of some of the stuff that we're doing with LLM. So essentially here, what I have is a bunch of patient data. So I created a RAG model using a bunch of fake patient data. And here, this is like the patient is essentially conversing with a customer support person. And then the customer support person can open up an internal AI system and ask the AI system questions. And what we've done is we've used that Skyflow Vault to essentially train the model on the clean versions of the data. So I can say something like, what is the patient's name? And when I get the information back, hopefully this works. Yeah, there we go. The patient's name is John Doe. The model actually never saw John Doe. So we look at essentially what the model seeing is essentially just seeing these like de-identified forms of the data. So we can essentially facilitate the same sorts of things that we'd want to do with LLMs in this particular example without, essentially training the LLM on the sensitive data that we can't essentially delete later.
Cool.
Yeah.
That's amazing. Yeah. So I might have to put you on the hook here, but I think you need to come back for one of our Code with CodingCat sessions, and we need to code this up live so we can actually like take a Next.js application, run some data through it, and like pull it back out. You game?
Yeah,
or
we can.
Someone on your team?
What's that?
Or someone on your team?
Yeah, we could certainly do something like that. It'd be fun.
I think it'd be cool. All right, we have to jump into our perfect picks. We're running up on time. I'll go first. Real simple one today. Happening if you're watching this in the future, which I got the wrong screen. There we go. We are going deep on Svelte 5. So Jason, Learn with Jason is going to have Rich on and dive into the runes and everything else that's coming out with Svelte 5. So I'm super stoked about that. And that's my pick for the day. Sean has a much, much more fun pick. Tell me about this.
The Devil's Plan. Yeah. So I haven't finished it. So, but it is on Netflix. It's a South Korean show. There's a South Korean show that I absolutely love called The Genius that came out years ago. And essentially it's a competition show for really smart people where they're playing these like games. So you can imagine playing like, I don't know, like a version of Mafia or some version of like made up poker or something like that. And they have like a main match, elimination match, and essentially they have an in-game currency. You're basically living within sort of like a board game or like a escape room or something. And The Devil's Plan by the same people, but is available on Netflix. So it has, it's easier to find and it actually has subtitles. But essentially a bunch of people, very smart people, are brought into this world, kind of Big Brother style, where they're all living in this environment, but the entire environment is a series of games. So there's main matches, there's games where there's in-game currency, there's other games that are set up to allow them to earn money to the prize pot that ultimately the winner is going to earn. But then there's like hidden games within the environment that they're living in as well. So it's a really, really cool show. I'm huge into sort of nerdy competition shows like The Genius, or a sort of social engineering shows like Survivor or stuff. And I've done a lot actually applying like machine learning to data sets from Survivor to predict winners and so forth.
Oh my gosh.
I've been able to combine essentially my love of data analytics and machine learning to the world of reality TV as well.
That's awesome. This sounds like an escape room with like challenge and prize money. Like that's so crazy. I'll have to check this out for sure.
Yeah, it's awesome.
Well, Sean, sorry to cut so brief, but then we're gonna. I loved Skyflow. It was amazing. Thanks for coming on. I loved your story about DevRel too. So huge props on your journey to make it to. Being a CTO is exhausting. So that's really cool. You saw an exit. That's awesome. And now you're on to the next Skyflow thing. This is sweet.
All right. Yeah. Thank you so much. It always sounds good in the Cliff Notes version, but hides all the pain and suffering.
Yes, exactly.
Yeah. Thank you so much for having me on. It was a lot of fun.
Absolutely. Anytime. Thanks, Sean.
Cheers.